So as we said on Friday, our targets for this lesson are to be able to fit linear models to data. And we want to be able to do this not only with our calculator like we learned about on Friday, but also we want to be able to do it by hand on graph paper. So that's what we're going to go over here today. Well, what we're doing here really is what's called linear regression. Whenever you fit a model to data, you're performing what's known as regression. Officially, we can see that regression is the statistical study of the relationship between variables. And our focus is on linear regression here in this section of Chapter 2. Now, when you fit linear models to data, one of the things that's going to come up on your calculator is going to be what's called the correlation. The correlation basically tells you the strength and the direction of the linear relationship. And the variable that's used for correlation is R. R is always some number between -1 and +1. And the closer that R is to either +1 or to -1, the stronger the relationship, the linear relationship between the two variables that you're looking at. So what you can see here in these graphs is that the first graph on the far left has a really strong positive correlation. I think you could picture fitting a line through the data somewhere around where I just drew that line, and those dots seem to be scattered fairly closely to that line. The middle graph also has a very strong correlation. Its direction is positive as well. But this graph on the right really just looks like there's no pattern whatsoever to the data in the scatter plot. So it really has a correlation very, very close to 0. So the lousiest correlation you can get is 0. So in example 1 in our note packets, we're asked to make a scatter plot for this data and identify the correlation, sketch the line of best fit, and find its equation. This is the data we looked at together in class on Friday. So I'm just going to review this example with you. What we did was we went to Stat Edit, and we have this on our graphic organizer. We went to Stat Edit, and in List 1, we plotted all of the times. They were our x coordinate, and in List 2, we entered all of the points scored. They were our y coordinates. And we plotted that on our calculator by setting up our stat plot to do List 1 and List 2. Then we fit a line to that data. And when we fit the line to the data, we did it by using our Stat Calc 4 feature. And when we did that, we found the equation was given to us in the form y equals ax plus b, where a is the slope and b is the y-intercept, where it crosses the y-axis. And this line can be used to make lots of predictions. Now, if we were fitting a line to this data by hand, we pick 2 points that lie on our line. So they may be data points that were actually in the data, or they might just be 2 points whose coordinates we estimate. And so I picked the point 2010 and 4025. And the first thing we always find when we're fitting a line to data is the slope of the line. And we know we do that by using our slope formula that we've learned previously. The change in the y's over the change in the x's. And that's what I've done here. So I've determined that my slope is equal to about 0.75. Then if you use point slope form, we know that slope goes right in here for m. x1 and y1 are the coordinates of any point on the line. So I used this point here, and I took the x and I plugged it in for x1, and I took the y and I plugged it in for y1. I leave y and x alone because every equation needs a y and an x. Then I wanted to get it into slope-intercept form, so I distributed the 0.75 to both of the things in the parentheses that followed. I added 10 to both sides of the equal sign, and what I ended up with was this equation in slope-intercept form. So this line has a y-intercept of -5 and a slope of 0.75.